Hey, welcome. So, why would I start and talk at a data hackathon showing you this picture? By the way, who is this guy? I'm glad you pronounced the name, so I don't have to. Why would I show his face? There are two possible things to come up with. Now, the more recent thing he did that people know him for is this one. Who has seen this movie? What was it called? The Imitation Game. He played the role of Alan Turing, who I encountered Alan Turing about the second semester into my computer science course. Work, and it was not the easiest of courses, but ultimately fun. But yes, the echoes.
You're saying right.
So, where do you want me to talk? Should I just talk like that? That better?
That's better.
Good. Let's do this. Thank you. Sorry. Okay, so Alan Turing. But yes, the first guess people had was actually writing. He played Sherlock as well. Now, still, what has Sherlock to do with your data hacking? I'll call it the data detective game. So I'm now what they call a data scientist. When I got into the business, and that was back in '95, I was very young, I was just being a geek, kind of a strange kind of geek. All of a sudden, it's like the greatest job on earth. I spent my time in IBM research, working in predictive modeling, many different problems. One of my claims to fame is not doing hackathons, but machine learning competitions in a day where Target didn't exist yet. But what keeps me motivated? What do I like to do? Why I do this? It's exactly this. It's the detective game of playing with data and finding out what might be hidden in there. And my point to you is a little bit of a reflection also from our hiring and so on. Good data intuition is incredibly important. And it's really, really hard to teach. It's very hard to find. It's one of the most important things to have in this game. That's the differentiator between good data scientists and great ones. It's data intuition. And that's what I call the detective game. I want to start with expectations. No matter what you do, before you even look at the data, you need to have expectations. You need to know what you think this should look like. Because every time you're wrong and you're surprised, you have a great opportunity to either learn something and get better at this data intuition thing, or to find something out about your data that is probably important and that you should know. So, key advice number one is have expectations about what you want to see. Because some of the most interesting examples in my learning and growing was when I discovered something that really was contrary to what I expected. So embrace it, don't brush it over. Let's start with mobile phone location data. Thanks to our previous speaker, I don't really need to introduce my job anymore. I work for advertising. Long way, I never expected to find myself in advertising. I grew up in East Germany. I hadn't seen an ad until age about 15, roughly. So it's an interesting career development. And we are getting real-time mobile data. Have you ever wondered why all the apps installed on your device want to have lab information and access to your GPS? Because they pass it along when they are selling ads that then show you, and it makes the ads more valuable if that information is provided. So imagine expectations, right? Location information coming from mobile devices, ending up with many, many companies that you don't even know that will see them. What do you expect to see? So let me ask you, the table of two locations. This one over there, and this one over here. They're both New York City, just to say. Now, first of all, why are they looking so different? Think about it, when you get this information from somebody's phone, why would they sometimes look like this, and sometimes look like that? Why does it matter? Well, it matters when you try to answer this question. Let's assume you get either of those. Which one is the person holding the phone closer to? I mean, I don't know where he really is, but the person is somewhere, right? I'm asking, what is the distance between where the person really is and where this information says the person is? Do you think the person is closer to this or closer to that? All right, show of hands for this one. Who thinks the person is closer to this? All right. Who thinks the person is closer to that? All right. What does it mean? Why do you think a person of the, I think it was a majority for this one. Why did people like this one better? More precise. Now think about it. Maybe I should have put it in some perspective. This is down to the millimeter. Do you know any GPS system that's even remotely correct down to the millimeter? That doesn't mean that you're not there, right? I mean, you could get the millimeter wrong. That's not the problem. The problem is nobody's there. At that precision, the only way I can get that precision of a device, it means it gives me the average, I mean, it gives me the midpoint, the center point of the New York DMA location that you can calculate with 50 digits. That doesn't mean the person is there. This is clearly a machine-generated number that has almost truly no or very limited bearing to where the person is in reality. And when you look at these kind of very high resolution numbers, what you see, for instance, that according to the data I get, 30% of the US population is traveling faster than the speed of sound. Because they jump from one 8-digit location to another one within milliseconds or seconds across the country. The other one, and I apologize, I didn't know the lighting would be so that I would have taken a different scheme here. If you look at these high-resolution backgrounds, you see piles of people showing up there at the exact same time, all standing on top of each other. And I can't quite imagine that either. So again, machine-generated numbers that don't mean what they pretend to mean. They just try to incentivize you to spend more monies on the ads to show the people. Great, excellent. Thank you. Let's look at a different one. This is a data set from a data mining competition where you had to predict breast cancer. We saw great discussion on medicine. This is a step back, not quite sophisticated. This is looking at fMRI data and trying to automatically detect whether or not there is breast cancer. So this data set here had about 1,000 patients and roughly 6% cancer rate. Now, I said something about patient identifier. Every hospital gives their patient numbers, right? That's the identifier. Typically, it's not the name because you don't want to share any personal identifiable information, so you have these kind of random numbers in there. What do you expect the distribution of such a identifier to look like? Just think about it for a moment. All right, here's what it did look like. This is the distribution, is log scale, by the way. So this is a histogram of the distribution of the patient identifiers in this data set. Anybody having a problem with this? This is not what I expected. Particularly, a whole bunch of people missing. I don't know what happened to them. Now, okay, reality be told, I'm not, the first thing I do when I look at a data set is make histograms of the identifiers. That's kind of how I tell the story. What I actually did is I looked at this data in the context of building a classifier for diagnosis. And what you see here is now breaking it up into these groups that you saw in the previous plot. I also showed the prediction score I get from a support vector machine. The key part here is that the red points are cancer. The green ones are healthy. What do you now see that strikes you as very interesting?
Correlation of therapy.
The patient identifier is by far the most predictive feature. Right? I mean, if you're unlucky, your number is low, too bad. So the reason we actually found this is because we looked at kind of the labels and we found that down here in this set, there was actually 30% rate of ones. And you just look at the thing, you look at the screen, there's just too many ones. It was supposed to be 6%, and every third one was positive. So what it means, we found something out about the data set, which I claim limits its usability for building a good classifier. Because even if you don't include the patient identifier, which arguably you shouldn't, there is still what we call leakage from different locations. This data set was compiled from multiple locations apparently. This is a treatment center, this is a screening center, and what you end up is different calibrations in the images. Like the average grayscale is different. So even if you don't give the model this information, it will still find it because modern techniques are very good at teasing out very little disturbances, and your model will look much better than it really is. It's not a problem of overfitting or out of sample. Even out of sample, this model will look great because it can pick up what location you're wearing. And that's something you have to consider if you really wanted to build a model for this task. I just wanted to win the data mining competition, so that was kind of the point. But as you think about the application, that's very important. It's the data set you have actually supporting what you're trying to do. And very often you find things wrong. My last case. That was over 2 weeks. The median performance over 100 campaigns doubled. When I say performance, it means how well can I predict that a person takes a certain conversion action, like going to a brand and looking at a product, maybe buying it, filling out a form to get on a test drive, this kind of stuff. Can I really, across 100 campaigns, double performance within 2 weeks? Is there any chance of this happening? Highly unlikely. But let me ask you this. Think of one of the websites you go to very often. Anyone, pick one that you use well. And now you think about the other websites you visit. And what is the kind of overlap? How many people who go to that website also go to the other one? All right? Think about what kind of numbers make sense and what affects this. Let's look at this. There's a website that I started out with, and here I'm looking at the overlap that I see with other websites that I see across all these cookies. So this means 55, that 55% of the people who viewed the website I'm asking about also went to YouTube. Fox News, Weather, Washington Post, LA Times, and so on. A lot of new stuff in here, the New York Daily News, New York Post. What do you think is the website? Which one?
The Huffington Post.
Huffington Post. Any other proposals? We're close.
Google? New York Times. Yeah.
New York Times. It's the New York Times. That explains actually why so much New York stuff shows up here. But your guesses would have been fine. This is the New York Times. Now, let's look at this thing. Same task. Who am I?
IMDb.
I would also like to point out the percentages on this side. And I have to disappoint you. You probably don't know me. I'm Hip Hop Havoc. Anybody of you ever been to Hip Hop Havoc? You? Why? Sorry, I mean, honestly, this is the first time I meet somebody who actually knows this.
I've been on it like 3 times because I work. The guys didn't think to, and I don't like Turing like that.
But just look at how much other stuff people look at who go to Hip Hop Havoc. Is there any way you see this to be reasonable? Does that meet your expectations? I mean, we have an expert here, right? Have you been to any of the other ones?
Drugs news.
So, what I'm showing you here is, in this comparison, this is what we call a normal site, and people who go there and go to those are actually real people. This over there is a subset of a bot network that is monetizing by basically screwing the ad networks and selling ads to people. You're the rare exception that 95% of the things who go to a Hip Hop Havoc aren't people. They are bots who also go to all the other stuff. So what happened here with my performance? Well, we'll get back to this. When we started digging into it, what we found out are, like Hip Hop Havoc, this one is Women's Health based, it was also on the previous slide. This website is super predictive across many, many different products, meaning people who go to Women's Health base also are likely to go to a pizza site, a luxury car site, be interested in Microsoft Office products, maybe credit cards and hotels. Right. Let me show you what that graph of that traffic looks like. If you start looking more deeply into these connectivities and we build a full graph, and we get all this information from bid requests, we receive about 50 billion bid requests a day, over something like 2 million cookies. I'm not sure every cookie is a person, as I'm kind of pointing out right now. So what you see, this is the world of 2010, and I'm only showing you the super connected stuff, meaning connectivities above 50%. Now, what does this mean? Let's take a look at one of these smaller things here. This is the Boston Herald. Expectations. Does it make sense that there's a 50% overlap between those different websites? It's actually very well possible. Often it's also technical integration that part of the website pulls information from a different one. So you expect to see some. That makes sense. This is kind of a human structure, humanly generated structure in this way. What about Women's Health Space? Anybody wants to guess where it is? Right there. Right there. Women's Health Space. Again, a lot of time to travel the web and surf and read all kinds of interesting content. Would like to point out the diversity of interests here. So we have China on TV, wrestling news, well, whatever the spelling, and other things. So this is that traffic footprint of bots that basically iterate through these semi-fake websites. That's not human. There's no way that any human does that. This is the plot from 2012. I haven't made one recently. I'm running out of real estate here, so start to see less and less. So this is a phenomena that we discovered, all starting when somebody said, look, we can't possibly be doubling performance. Now, I haven't quite gotten to the point why our performance will double. Why is it double? It's because the bots fake performance too. There are a lot of metrics in advertising that are easily spoofed, like clicks. There's a whole slew of techniques how you can fake clicks. Now you can also fake landing pages and many of the other things. For instance, if you look at just the bot traffic by different typical kind of conversion events that the advertising industry is counting, like video completion. Video completion is one of these metrics that you're being paid for. Turns out that about nearly 70% of all video completions done by bots. They have a lot of patience watching through these 30 seconds ads that nobody else actually gets through otherwise. That brings me full circle to the other person we started with, Alan Turing. Because Alan Turing posed a very interesting test, the Turing test, where he said, I'm willing to call a computer smart if he can fool me into believing he's human. Obviously, we're not talking about speech interaction, it was just typing in the keywords. I pretty much have the exact same problem. I need to decide whether you're a bot or not, because I don't want to show ads to bots. I don't think that's the right thing to do. So, coming back to Alan here, we built a bot detection system, and yeah, they went back for performance. We're back to normal, almost normal, by basically ignoring all the information provided by bots. It's very easy to predict for a bot that bot will actually have the patience to sit all the way through the video content. Bots are much easier to predict than people. And that's why my models were trying to kind of optimize towards these events, started picking up all that bot traffic. So here it went away. And with that, I want to close following kind of higher level. Trust your instincts. Hone your intuition. And whenever something strikes you as odd and you see in your data, go dig. It's a lot of fun. And often you will find something tremendously valuable in the process that really matters, ultimately affects your business. With that, I'm very happy to take any kind of questions on whatever it is you want to know.
Is there a service to find out attributes from the domain name?
There is very little in terms of the domain names. You saw how different they were. Ultimately, what turned out to be, many of them were owned by a company called AlphaGrowth, which by now has renamed themselves into something else. I don't know what they're called today, but it's like a spam problem. It's an adversarial problem. They keep doing it. We keep trying to detect them, and so it keeps going. The only giveaway is it only works if you act on scale. You can't make the bot scam work if you have no scale, so you have to have a lot of traffic, which always ends up showing up on my radar. So because they have to scale it, that's where this traffic overlap thing remains to be quite effective. You also detect, for instance, spoofing. All of a sudden, one of the sites having very high overlap was the New York Times. Now, don't quote me on this. Turns out the New York Times is buying traffic on occasion to fulfill their advertising needs. But even besides that, there are many fake websites pretend to be the New York Times, though they are sending bid requests into the system saying, hey, I'm the New York Times, you want to show an ad here? Turns out they're not the New York Times, they just changed the URL. And you find that too. So it kind of, there's always something fun to detect with these environments. Yeah.
So I think you made a great case for a commission. What advice do you have for these students how to build commission, how to improve their commission?
So first, I would say you have to embrace kind of the randomness of the world. And my understanding of data has changed. I don't believe in dirty data, or I believe data is what it is. I may not know what it means, but that's kind of my failure to understand it. A click doesn't mean a person was sitting there, was interested in the ad, and chose to go and read more. That's an interpretation that most often is wrong. 99% of the time, there's a better interpretation. For instance, if you want to run a really great click campaign on mobile, all you need to do, no matter what the ad or the product, run it on the flashlight app. It's a whole bunch of people fumbling in the dark. They will click on your ad for sure, sooner or later. So they clicked on it not because they were interested. I'm not even talking about bots and fakes. It's just the environment makes those things accidental. So that's the first part. Make sure you understand what it really means. The second part is I need full control over the data collection process. I know you can't always have that, but if you remember the breast cancer case, we had to backwards engineer the fact that the stuff came from actually 4 different locations. I shouldn't have to backwards engineer this. I would always want to be part of the collection. I want to understand how it came to be. So that's kind of the beauty of big data and the idea of collect everything is I can now go back to the quote-unquote raw data and pull the actual event logs by timestamp and get a much better understanding of what that stuff actually means.
So you're kind of pointing at measuring intent and prioritizing and distribution. And so how do you think that will be measured?
Well, I'm saying that almost every measure that can be gained will be gained, and that with powerful machine learning algorithms, the moment you make it kind of a primary metric, you're almost surely going to get yourself a really, really good goal. For instance, viewability is another one. The only thing you can truly measure is things that cost money. Because bots still today hate to pay for stuff. So they don't actually buy things. Now the problem with that is it becomes a statistical problem and so on. There are very interesting metrics around observational methods for cause estimation. So you can actually measure the impact of an ad. The problem with that is bots also have a very high impact because they on purpose after seeing the ad go there because they pause on the landing page. So that doesn't help. The causality isn't actually the solution here. But I think in general that's a more interesting direction of marketing. Yeah.
This might be a naive question, but it seems like in the past 10 years, data science and big data have grown from this initial concept where you could utilize it, and people are giving away data for free, something that now companies are getting it from people that are storing it. It's like a private, it's treasure essentially. It's almost like data has become commoditized. And I was curious what your thoughts are on how the ecosystem might evolve if people were to become involved in actually selling their own data for an equivalent exchange of value. Because right now it seems like companies are getting data from people, they're converting that data into monetary value through internal systems, but the people themselves aren't benefiting directly from this. So do you see a sort of secondary market forming up in the future where people can directly sell data for obscure cases and sort of monetize their own personal information?
So everybody have questions? It is about it's kind of, there are big companies collecting data for free. Is there going to be, or might there be a market where you can monetize the value of your own data? I hate to break it to you. Your value is useless. On a single, the marginal value of one more data point is as close to zero as you can possibly get. It only becomes valuable en masse. And this is, I think, today still the biggest problem of the idea of how to monetize data. It's very hard to price a single data point. It's really useful in aggregate. As a single data point, it's problematic. And once it becomes self-selective, if you want to sell me yours at what price and so on, the sampling biases we're going to get makes even the set of data less valuable than it currently is. So I'm not too optimistic. Now, I work in advertising. That wasn't really kind of my primary goal in life. But if I do need to kind of pump myself up a little bit, just look at it as the modern form of Robin Hood. It's transferring money from rich brands to infrastructure you take for granted, to new sites you access every day for free. You expect to access every day for free. That is paid somehow. Well, it's not exactly true that your data isn't being monetized for your benefit. I'm not even going to argue that the apps are relevant and useful. I'm saying you get a lot out of the data being available as it stands. So that's my somewhat practical. Can be more. All right, I think I'm getting to the end of my time. I'm happy to hang out a little bit more. I will be back tomorrow, so if people want to talk to me about career or anything else, I'm very happy to engage. If you Google my name, you can always connect to me on LinkedIn. Please tell me that you met me here and give me some kind of context, and I'm very happy to connect. Thank you.
Okay, everybody. So, how many people have a problem that they wanted to pitch up here? It needs to get some team members together. Is there anybody? Okay, why don't you guys come on up? Make a line over here. You've got 60 seconds to pitch your idea. Okay. So, a word on the mic, don't hit your cell phone. Okay, like right here. This is like the sweet spot with the mic. Okay.
You have to pitch your idea, what you're looking for, and what's your background.
Hi, my name is Jen, and I am a senior at Cornell.